Hi, I'm Sorin Vatasoiu Jr., and I'm a junior at Neshoba Regional High School in Bolton, Massachusetts. And I'm the captain of RoboTeen, a robotics team. For the 2012 Trinity Firefighting Competition, we built FireMonster 2. The Trinity Firefighting Competition is held annually, and its goal is to have autonomous robots compete to find and extinguish a lit candle in a maze. The robots need to be capable of navigating the rooms, identifying the flame, and extinguishing it within 5 minutes. Extra points are given to robots that can deal with variable doors, returning back to the starting point, using sound to start the robot, or variable candle location. The competition is split into different divisions, mostly based on age. For this year, we will compete in the senior division. Another part of the competition is the Olympiad and the poster competition. On the Olympiad, members of the team are tested on their knowledge about robotics. And for the poster, this video will represent our creation. Our robot, FireMonster 2, is based on last year's FireMonster 1, which won several prizes in last year's Trinity competition. We kept the parts that worked well and changed the ones that did not. For traction, we are using a differential drivetrain made with parallax continuous rotation servos. Contrary to last year, we're using larger, wider wheels for increased stability. These wheels are connected to homemade optical encoders that help the robot to control its movements. Since the robot cannot touch the walls, we are using sharp infrared proximity sensors to get a sense of how far we are from the wall. We're using 2 sensors on either side and 1 in the front. To detect the white lines marking the entrance to rooms, we are using 2 color reflective sensors. Since movements are not 100% reliable, we are using 2 switches as bumper sensors to detect accidental contacts between the robot and the wall. To extinguish the flame, we use carbon dioxide contained in a PVC container, which is controlled by a Versa valve, which in turn is controlled by a relay. For flame detection, we use a smart infrared camera that can see if a flame is in front of it and gives us the coordinates of the flame. This camera sounds like an expensive part, but in fact it is one of the cheapest parts we used, as it is from an old, broken toy, and we got that toy for $3 or $4 at a yard sale. The camera can pivot in such a way that it can track the flame even if it is not straight in front of the robot. As for the brains of the robot, we are using an Arduino Mega board with 128 megabits of memory. The whole robot is powered by an 8.2-volt rechargeable battery. We estimate the cost of the robot to be around $200, without the price of the Lego parts. The robot is built 100% by us, from scratch. Since the ramp is mandatory this year, we paid special attention to the design of the robot in order to achieve a well-balanced robot. We placed the heavy parts close to the ground and installed wider wheels. The robot movement is controlled by a PID algorithm that reduces the wobbling when the robot is following the wall throughout the maze. To reach the final design of FireMonster 2, we went through several different prototypes. Here are some of their designs. Let the best robot win.